Hey everybody, today we're going to look at terminating and repeating decimals as well as number sets and how to classify different numbers. Okay, so both topics have to do with one term can be used when talking about both topics, and that is a rational number. Okay, so a rational number is any number that can be written as A over B, so in fraction form, where both A and B are real numbers. Okay, real numbers. Okay, and also B cannot equal 0. Okay, so what that means is, some examples is like the number 1. Well, 1 can be written as a fraction, 1 over 1, right? Both of those numbers are real numbers, and the denominator b is not 0, so that's good. If you look at another example, like let's just say -6, right? That can be written as a fraction, -6 over 1. Okay. Now, if you have a number like 2.5, that can be written as a fraction. Okay. First, if you converted it to a mixed number, that would be 2 5/10. And then if you converted that to an improper fraction, you'd get 25 over 10. Okay. So a rational number is just any number that can be written as a fraction. So moving on, okay, we also have two different types of decimals that can be rational numbers. The first one is a terminating decimal. Okay, so a terminating decimal is a A terminating decimal is a decimal that ends or stops. An example of this would be like 0.25, right? It stops at that 5. It doesn't go any further, so it's a terminating decimal. All right. The other type of decimal is a repeating decimal. So a repeating decimal is a decimal that has a repeating pattern that does not end. So an example of that would be like 0.3333333, right? And you can go on forever and ever and ever. Okay, that's a repeating decimal. The 3 is repeating. It's showing a pattern, right? So that would be a repeating decimal. All right. Now, in order to more efficiently write a repeating decimal, we use a bar written above the repeating numbers. So, for example, that 0.3333 would just be 0.3 with a bar above the 3 because that's what's repeating. And how you would say that is 0.3 repeating. Okay. Now, to write a fraction as a decimal, you would have to divide the numerator by the denominator. So we should be familiar with this, but we're going to do some examples here in a second. Okay, but all you have to do is divide the numerator by the denominator. Now, if the fraction is a mixed number, you must first change it to an improper fraction. And we have one of those examples as well. An improper fraction. Okay, so let's look at the two examples down below. Okay, so the fraction 2/9, we're going to be dividing the numerator by the denominator. Okay, so another way I just say this is the bottom, the bottom goes out. Okay, so 9 is on the bottom, it's going to go on the outside, 2 goes on the in. Okay, now will 9 go into 2? No. Now anytime you have a number, to the right of that whole number is a decimal. All right, and you can just extend that number by adding a 0, okay, because that does not change the value of that number. Now, will 9 go into 20? Yes, it'll go in there 2 times. Also, make sure that decimal comes straight up. Okay. And then 9 times 2 is 18. And when you subtract that, you get 2. Add another 0 because we still have a remainder here. So we're going to try to keep going until we don't have a remainder. Notice we have 20 again. Well, 9 will go into 20 2 times. You get 18. And now you're left with 2. We still have another remainder, so we add another 0, drop it down. Oh, we get 20 again. So notice we have a pattern. We get 20, 20, 20. Okay, that's your pattern. So you know that no matter how many times you keep doing this, it's just going to be a 2. So that's obviously a repeating decimal, and the proper way to write it would be 0.2 with a bar indicating that it's repeating. Okay? Now let's look at the next example. We have a mixed number. Not only do we have a mixed number, but it's also a negative. Okay? So when we're doing these type of problems, don't worry about the negative until the end. Okay, that's how I do it with the mixed numbers and dividing and all that. Okay, so to turn it into an improper fraction, we multiply these two numbers. So 3 times 4 is 12. Then we add that numerator. So we get 13, and then the denominator stays the same. So we get 13 over, oops, that should be a 4, sorry. We get 13 over 4. Now, we still divide the numerator by the denominator. So we're going to have 4 on the outside and 13 on the inside. Okay. Now will 4 go into 1? Well, 4, first off, 4 will not go to 1, so we go to 13. We'll go into 13 3 times, and 4 times 3 is 12. So we subtract, we're left with a 1. Remember to add your decimal there, and it goes straight up. Add your 0, and it goes straight down. Now will 4 go into 10? It will go in there 2 times. 4 times 2 is 8. You subtract that, you get a 2. Add another 0, bring it down. You have 20. Will 4 go into 20? It'll go in there exactly 5 times. So when you subtract that, you're left with nothing. Okay. So this obviously terminates right there at that 5, but don't forget it's also negative. Okay, so you get negative 3.25. Okay, and it's a terminating decimal because it stops. All right, so that's it for terminating and repeating decimals. So let's go ahead and look at number sets and classifying numbers. Just like everything in the world, we have a way of grouping things together that have like characteristics to make it easier, and numbers are no different. So we have a number system that actually classifies numbers for us based on their type and their characteristics. So this is going to be classifies, sorry. Sorry, my handwriting is a little bad. That's an F. So classifies numbers based on their type and characteristics. Now we're really looking at 4 main ones, and that's natural numbers, whole numbers, integers, and rational numbers, which we already talked about. Okay. So a natural number, the set of natural numbers, okay, that's also called counting numbers. So that's numbers that you, whenever you learned first how to count, 1, 2, 3, 4, and so on. Okay. So this is the set of all positive integers. Oops, positive integers. Okay. So like I said, it's just examples of what you first learned how to count. That's why these are also called counting numbers. That'd be 1, 2, 3, 4, and so on. Okay. Now, whole numbers, the only difference is we add the number 0. Okay. So really, you have 0, 1, 2, 3, 4, and so on, right? It keeps on going. So the only difference for whole numbers is it also includes 0. Okay. Now when we get to integers, that's the set of all whole numbers and their opposites. Oops. Okay, well the Formal definition of an opposite means it's the same distance from 0 on a number line. So if you have the number 1, okay, 1 is 1 unit away from 0, so the number that's also 1 unit away from 0 would be -1. Okay, you have 2 and -2. Okay, and so on and so on and so on. All right, now that also includes 0 as well. Okay. Now, rational numbers we already talked about. It's any number that can be written as a fraction. All right. So there's also two types of decimals that we know can be written as fractions, and that's why we include them as rational numbers, and that's terminating and repeating decimals. So we already talked about both of those. Okay. So if it's terminating or repeating, then it is a rational number. Examples of rational numbers, okay, you like -2.5. Whoops, that's not a very good 5. Okay, or 3/10. Okay, now keep in mind that the rational numbers also includes all integers, whole numbers, and natural numbers, right? It's just adding those fractions, terminating decimals, and repeating decimals as well. So this chart, and we'll look at one similar to this in class, but this chart really has a good representation of the 4 different number sets. Okay, so if you look at the most basic one we talked about was natural numbers, so that goes in here. Whoops, let me get my pen. So we'll do that in blue. This is natural. Okay, and then after natural, okay, you have whole numbers. Now, notice how natural numbers falls within whole numbers, right? Because the whole number is this entire box right here. Well, look what's included in that. Natural numbers are included in that. So whole numbers are natural numbers and 0. Remember, that's the only thing that's different. Okay, as you keep going with the different numbers, you have to remember that each one is a subset of another one. Okay, so the next one, we'll do that in a different color. We'll do that in this color. That is your integers. Okay, and remember, integers is this whole box right here. Okay, well, what does that include? That includes all the whole numbers and the natural numbers, and then you're just adding the opposites like -1, -2, and so on. Okay, so that includes all whole numbers, all natural numbers, plus those new ones. And then the last one that we're talking about is rational numbers. Rational. Okay, so again, notice it includes integers, whole numbers, and natural numbers. Okay, that's all inside that box. Now we're doing fractions. We're doing repeating decimals, so like 0.3 repeating, and we're doing terminating decimals, 0.25. Okay, those can also be negative as well, right? So we're including all of those, and we'll talk more about that in class and as we continue throughout the year. Now look at this question right here. It says, is it possible for a number to be both a whole number and an integer? Why or why not? Well, look at the whole numbers. Okay, whole numbers includes all natural numbers. So let's pick a whole number. 3, right? That's a natural number. It's also a whole number. Is it an integer? Yes, it is, because it also falls in the integers, because integers are all whole numbers and all natural numbers. So yes, it is possible. 3 is just one example of that. All right, I hope this video helps, and like I said, we'll talk more about it in class.